Alright, this little video, hopefully it's really short, is going to go over how to accomplish the last two questions, how to go about it. So really what we're going to do here is to extrapolate from previous data. This here happens to be in cumulative installation of solar. And this here is just the data in an Excel file from this chart here. So we're going to extrapolate, we're going to find an equation in Excel and use that to extrapolate what we would project for 2050, how much solar energy would be in the grid in 2050. So I think this makes sense here, at least to start. This would be the base year starting in 2011. Call that year zero, and that's how many megawatts of installed power there were. So here is our first chart, and this is using solar, and this is the data. And basically, I highlighted all the data and created a chart, and then created a trend line. So this is a linear trend line that has an R squared of 0.96, which is really high. So this is actually what you're going to do, and you're going to use this trend line in order to extrapolate how much solar we will have in 2050. So that would be 39 years after the base year 2011. Now here is the same data, and what I did here, used the data, created the same graph, but for the trend line, I use an exponential growth trend line. And if you look at the exponential growth, it says it's 33%. And the R squared also shows that it's a good fit. But if you're going to extrapolate 39 years out with an exponential trend line, it's going to cause a lot of problems. So we're not going to use this, and I want to show you why this will simply not work. So here's a hypothetical starting in 2010, which you're going to call year zero. And this is hypothetical. There was certainly a whole lot more than 100,000 solar panels in 2010, but just as an example. So I increased it each year by 33% from the previous year. And you can see that by 2050 here, there's more solar panels than there are people on the earth by a long shot. And that's in 42 years from 2010. That's utterly absurd and impossible. We're using the linear model. And look at the installed wind capacity. And you're going to make a chart out of this, and you want to get, there is the linear line and there is the exponential model line. They're actually both pretty good, but from previous discussions, we're going to use the linear regression line. And so you'll want to find that and then extrapolate from that. Now, it may look like wind is increasing faster than the linear model, but there's a couple issues. I just want to go into them briefly. Germany has been the leading installations of wind power in the world, but they're starting to run into some problems now, and here's what they're saying. New onshore wind energy is in steep decline in Germany, and it's due to people not wanting to see these things. So local residents protesting in many state parliaments that wind farms need to be a minimal distance from residential developments. So as a result, the licensing of these machines has slowed down. Permitting has gotten much slower. And even in the United States, in Maine, this is a large protest by lobstermen protesting offshore wind power because they're concerned that the lobsters will not crawl over the lines that come from the wind machine to the onshore. And the other really major issue is these are the minerals that are needed for solar, wind, and cars, electric cars. And there's just not enough production of these kind of minerals. There's lithium, which is the biggest mine. Aluminum takes a lot of energy to make. Copper is huge in all three of these, and there's just not enough mining going on in copper. So it's going to take time to respond to get minerals also. So just a quick overview here, just as a summation. These are the two Excel files that you have, that you download and work with. The first one, you're just finding the average of the Michigan kilowatts per square meter per day. This is this data, so you're just finding the average there. And you'll read about it. But you want to find it, and then you want to, here's the solar that you'll use for your linear model, and here's the wind, installed wind that you'll use for your linear model. And of course, you'll put the graphs in with the linear equation that you grab. And of course, you want to submit this file with the project. And good luck on it.